Hi friends, today let us discuss about finite state machine. We'll be discussing the first type of machine, that is finite state machine, which accepts regular languages. As set in the hierarchy, finite state machine accepts the regular languages, which are defined by the regular grammar, also represented in the form of regular expression. Finite state machine is a computational device having a string as input and having one of two possible outputs, accept or reject. It is also known as finite state automata. Let us discuss how to design a finite state machine. Finite state machine starts with an initial state, also known as start state, represented by a circle with an inward arrow into it. This state can be labeled with any uppercase or lowercase or any symbols. Every FSM will be having one and only one initial state or the start state into it. The final state or accepting state is represented by double circle. So you can see here two circles and the state is labeled as Q1. So this represents that the state is final state or accepting states. And here you may have one or more number of states marked as final states, but minimum one state must be there in the finite state machine to check whether the given string is accepted or rejected. A state which is neither initial nor accepting state is called as intermediate state. For example, in this small FSM, Q0 is the initial state, Q2 is the final state, Q1 is an intermediate state. And from Q0 state, for input A, it is going to Q1. Again, from Q1 for input A, it is going to Q2. So, till now we discussed how to represent initial state, start state, final state or accepting state, intermediate state, a path from one state to another state through a input symbol represented by summation. Input string is fed to the finite state machine one symbol at a time from left to right. Each time it receives a symbol considering the current state and the new symbol going to the next state. For example, current state is Q0. For the new symbol A, it is going to the next state, that is Q1. Similarly, current state is Q1. For the new symbol A, it is going to the next state Q2. And if the machine runs out of the input and is at the accepting state, then the string is accepted, else it is rejected.
Let us see how to design some simple finite state machines. For example, assume summation is A, that is, the alphabet summation consists of only one symbol, that is A, and the language to be generated consists of only one string, that is epsilon. Then the finite state machine for this language is represented as initial state itself is the final state. So, if we represent initial state as the final state, then the string obtained is epsilon.
In this example, the language contains only one string of length 1, that is A. To design a FSM of string length 1, we need two states, Q0 and Q1, where Q0 for one compulsory transition for input symbol A reaches final state Q1. So this is the FSM for the language containing a string A. Let us consider a language consisting a string of length 2. FSM for a string of length 2 needs three states, Q0, Q1 and Q2, where from Q0 for a compulsory A reaches Q1, and again from Q1 for the second compulsory A going to the final state. So from the start state Q0 for input string A, it reaches the final state Q2. Hence string AA belongs to this particular finite state machine.